Our second method to find Norton and Thevenin equivalents is using the VOC REQ method. And let's do it with this particular circuit. This is the same circuit as we analyzed using the first method, but let's say we weren't able to simplify it for whatever reason. Instead, we're going to begin by finding VOC. And we'll do it by finding any method of nodal, mesh, whatever. Let's start off by looking at nodal. If we put ground down here, we know what this node is. And so we've only got one unknown node, and that's our VOC. So that seems like a pretty good method to use. We'll sum up our currents at our top node. So here's our top node here. The current going to the left of that node would be VOC minus 20 over 4. The current going down through the 12 ohm is VOC over 12. And the current going down through that 2 amp source going up is minus 2. And the sum of those currents has to be equal to 0. So we can now combine our VOC portions. We've got a quarter from the first term. We've got a 12th from the second term. And all that equals, let's bring the constants to the right side. So we've got 5 from this 20 over 4, and we've got plus 2 over here. We can simplify this 1/4 plus 1/12. We can multiply everything by 12, and we'll get 3 plus 1 equals, let's see, 7 times 12 is 84. So therefore VOC, 4 VOC equals 84, and VOC has to be equal to 21 volts. The second part of method 2 involves zeroing our sources. And a 0 volt voltage source is a short, a 0 amp current source is an open, and we want to find the equivalent resistance between those two terminals. It should be pretty clear that those two terminals share both a top right side, but they also share a bottom left side node. So they are in parallel. And that gives us 4 in parallel with 12. And we can figure that out through a variety of methods, the one that I gave last time, or you could say it's equal to product over sum. So product over sum says it's equal to 48 over sum over 16, and that's equal to 3 ohms. And now that we know that REQ is equal to 3, we can redraw our circuit with our VOC in series with our REQ. And you'll notice that this, which is our Thevenin, or which we could do a source transform, divide the 21 by 3 to get our 7 amps, in parallel with a 3 ohm resistor, for our Norton, that this solution is the same as we derived previously using method 1. In general, method 1 is faster. I'd use it when you can. And if you can't simplify it using method 1, bring out the big guns using mesh or nodal to find VOC and use method 2.